It's phyllite.
Phyllite. I got it.
But let's see if it fizzes.
Oh, yes.
No,
Even heat.
no, I don't think
I'm not
so.
seeing any bubbles at all.
Okay, this is beginning to develop a cleavage. See in this direction here, it's a little bit in this direction. The bedding is nearly horizontal. Now, that's a bit of a puzzle if you think about it. Again, I haven't talked about this yet, but if we've got a fold, the fold develops perpendicular to the pressure. If you push the pressure this way, the fold is going to be like this. And cleavage that you develop, remember I said cleavage is developed by pressure? You get the sheet silicates forming perpendicular to the pressure. So that means if you've got cleavage associated with a fold, the two sides of the fold are going to be symmetrical around the cleavage. So if I've got cleavage like this, and one bed here, the other bed's going to be like that. You follow the reasoning? Now right here, the cleavage is like this, and the bed is horizontal. Well, if the cleavage is a sort of a mirror, that means the other bed is like this. Oh, that means this fold is like that. The fold is turned over. It turns out the Blue Ridge is an overturned anticline. It's a fold that's been laying on its side, and the reason you find that out is locations like this, where you get to see the cleavage, and it dips at a shallower angle than the fold actually. Or one of the beds on the fold dips at a shallower angle than the cleavage. Also, none of the rocks we've seen so far developed any cleavage. This is the first one we've seen that has any metamorphism at all. And it's just very, very low grade metamorphism shown by the cleavage. I don't even think this is up to phyllite, because it's just barely beginning. As you go further and further east towards the center of the collision, the metamorphism gets stronger and stronger. By the time you get to the Washington area, you're beginning to get things like gneiss and migmatite. Some of the rocks are even beginning to melt. But this is just the very beginning of it here. The further you go, the more of it you get to, the heavier the metamorphism you get to see. Okay, and these rocks, the age of these rocks is not really known very well. This lies underneath the carbonates. Matter of fact, these have been pushed up and over the carbonates in that fold. The carbonates are over here underneath the fold. So we know they're older than the limestones. How much older? Well, there are no fossils in it. Nobody's found any. There might be. Nobody's ever found any fossils in it yet. That doesn't mean there aren't any. Maybe there are. But if you find some, let someone know. And there's no way to radiometrically date this. Maybe you could find something that you could get a radiometric date on, but it wouldn't be zircon because there are no igneous rocks here. And if it's something else, sedimentary or very low-grade rock, all you would get, it would be reset by the metamorphism. So if you could get a radiometric date, it wouldn't give you the age of the rock, it would give you the age of the metamorphism, which isn't the same thing. So, if you can figure out a good way to date these rocks, let someone know.
Let you know.
Yeah, it'd be a good PhD thesis because it's been a puzzle for a long time. Okay, it is now 2:30, and it's probably about an hour and a half back because we've been working our way back all day. So, I'm not quite sure what the best way is from here. I'm going to leave you off and someone else, and I'm going to cross the Blue Ridge on US 40, which rejoins 70 on the other side of the Blue Ridge in Frederick. Or you can go back that way and find the nearest road that cuts back up to the interstate.